wait. Okay, now we will connect with electronics and communication. After that, we moving in this advanced network technology and hybrid electronics lab. This is the digital electronics lab. This is the basic electronics and electronic device and circuitry lab. Now we will connect with basic electronics lab. Now this is the some experiment maybe. These are the some introduction part. What are the virtual laboratory? In COVID scenario, we use the virtual labs. So these are some experiment related to the basic electronics. We can find out like this is the BJT common characteristics we can use, and this is the full wave rectification by diode. This is the half wave rectification, and this is the characteristics of diode. Now we will click on this VI characteristics of diode theory. What is the theory? First of all, objective is explain the structure of PN junction diode. You can find it here. After that, explain the PN junction diode. Explain the forward and reverse bias of silicon diode. Explain the forward and reverse bias characteristics of germanium diode. This is the plus minus that characteristic structure of PN junction diode. Diode is a device formed with a junction N-type and P-type semiconductor material. The lead connected to the P-type material is called anode, and the lead connected to N-type material is called cathode. In general, the cathode of a diode is marked by a solid line. This is the this is the cathode, and this is the anode. We can represent like this. The function of p junction diode in forward direction means battery is connected P side and negative N side. It is called the forward direction. P type region and the electron N type region are pushed towards the junction and start neutralize the depletion zone. Reduction of width is reduces the positive potential applied to the P type material repels the holes, while the negative potential applied to the N type material repels the electron. The change in the potential between P side and N side decreases or switch sign with increasing the forward bias voltage. The depletion zone eventually becomes thin, means the zone electric field countered charges carries the motions across p-n junction, which is a consequence reduces electrical resistance. The electron that the p-n junction diode, the p-type material or holes cross the n-type material will diffuse into the nearby neutral region. The amount of monitoring diffusion near neutral zones determine the amount of current that may flow through the diode. After that, this is the simple functions. Function of p-n junction diode for the reverse bias. Just we connect negative terminal to the positive side of the source, and the positive the p-type of diode is connected to the negative polarity of the negative side of the source. So this will be effect of the reverse. What is the forward direction of the biasing? This is the current. When we apply the forward voltage, initially there will be less current, no one electron is flowing. After some points, the 0.5 and zero point 0.6 volt between, there will be a small rise, and after that we can see here after zero point 0.6 voltage applying the current is flowing. For the reverse biasing, and you can check here the formulas, and when each model are used is also is there. Now we will work for the procedure. These are procedure used for the simulator. Forward bias silicon diode, set DC voltage the point 2, set the diode, set the resistor. Voltmeter is replaced by parallel to silicon diode, and the ammeter in series with resistor. The positive side of the battery to pitch side and negative side with the N. Now vary the voltage up to 5 volt. Note the voltmeter and ammeter. For particular DC voltage, take reading and note voltmeter readings across the silicon diode. Ammeter reading, plot VI characteristics graph and observe the change. Calculate the dynamic resistance of the diode. After this, therefore the graph, we see the diode is conducting when the forward bias voltage exceed around this. This is the whole setup. Let us start with, and for the reverse bias, set the DC voltage to 0.2, select the diode, set the resistor voltage. So now we will use these four type of experiment. First off, we use the simulator, forward bias silicon diode. Let us start serial number. This is the simulator. Just put it here, the value of DC volt. So what are the procedure? Procedure is the set DC voltage to 0.2 volt. Now we will set DC volt to this is the DC volt. DC volt should be set up 0.2 volt. Okay, I am reducing the value 0.2. It is very less. Oh, sorry. This is the 0.2 volt DC. Now select the diode. Select the diode. We choose iron 400. This is the forward is 0.6. If we choose this is the 0.6, and if we choose this is also zero point 0.5, and this is the 0.62. So we choose this 0.6, and after that set the value of resistor. The resistor value, now we just put the value of resistor 500 ohm. Okay, this is the resistance value, the 510. Now just look, voltmeter is placed parallel to the silicon diode and ammeter series with resistor. This is the voltmeter is parallel with silicon diode. This is the voltmeter, and the positive side of battery to the P side of anode, the same is connected is here. Now vary the voltage up to 5 volt and note the voltmeter reading for the particular DC voltage. Take reading and note down voltmeter reading across silicon diode ammeter and plot VI characteristics, the change. Let us see. Now we will increase the voltage up to 5 volt. This is the voltage. Now I am increasing the voltage. Look it here. The voltage DC volt is zero point 0.9. This is the zero point 0.9. Current is 0.55. Voltage is 5.5. Add to table. We choose it here, and after it we will vary to 1.4. Add to table. Now vary again 1.6, 1.8. This is the current 2.35 ampere. Add to table. One vary DC volt. Add to table, and this is 2.6. Add to table. This is 3. This is 2.8. Add to table. This is 3.8. Add to table. 3.7. Add to table. VDC 4.1. Add to table. This is 4.4. Add to table, and up to 5. Add to table. This is the variation of the. Now we will work. Take reading, note down the bold reading, silicon, and meter reading, plot VI characteristics and observe the change. Now we will plot the curve. Okay, we can just use the plot. This is the plot, and this is simple. A graph is plotted. This you can take a print here. You can take a print also, and it will be shown in, and you can use this. Okay, now we
जी
will
सर.
work for the second direction. This is the. Okay,